First of all, let me say thank you to everybody joining us here for our webinar on the KinetiClean HRSG tube cleaning technology. Welcome. Today we're sitting on the first part of a four-part series that we're doing with Groome Industrial Service Group. The other three parts will be happening over the next few months, and so you can be on the lookout for mailing regarding those, as well as on LinkedIn. Those parts will actually be system analysis, CO and SCR catalysts, as well as industrial coatings. So be on the lookout for those, and it'll be a similar format to what we're doing here today regarding the tube cleaning. First of all, I wanted to introduce our team that's going to be on the webinar. We have Matt Cohen, who is our technical sales rep for the Northeast. You have Jack Deaver, who is our technical sales representative for the Midwest. And then you also have Ryan Esposito, who is our engineering manager. And all three knowledgeable gentlemen who will be able to answer questions and go through the technology that we're offering today and discussing today. One of the things to let you know, we are recording the webinar. We will be able to send out a link to it, to an edited version that you can then see and view at a later time, and even share it if you will. In addition, we'll actually be doing questions and answers at the end. The idea is that this will be about a 45-minute or so discussion, followed by 15 minutes of question and answer. What I would say is that at any point you have a question, feel free to ask it on the chat. I'll be monitoring it, and my hope is that I will either interject the person speaking if it's relevant at that time, or we'll just hold them to the end and then answer them at that point. I myself am Jorge Godina, VP of Business Development for Groome, and I'll just be hosting today. So with that, we'll get started and discuss with you the KinetiClean and HRSG tube cleaning. So the first thing, as we get into the actual discussion, I see a lot of familiar names on the attendee list and people who have actually joined already. So a lot of you, I'm sure, are familiar with Groome. For those of you that are not, wanted to give you a little bit of background. And even for those of you that are familiar with Groome, you may not know all of the things that have been going on recently. So Groome Industrial Service Group, headquartered out of New Jersey, been in business for over 50 years, with the last 30 or so with heavy involvement within the power plant space. We're involved with the catalysts, change out, cleaning, testing, tuning, all of those aspects on the catalyst side, as well as some industrial coatings in the arena. So a lot of specialized service work within the power plant side, and we do that on a nationwide basis. One of the things over those 30 years that we've developed is an expertise in the areas of the catalyst side, as well as in that HRSG side. And with time, with that experience, we've determined that there was maybe different ways of doing things to make sure we were bringing the most value to our clients. And that's why you'll see there are two companies listed as part of the Groome family, and that is X-Pro and Blasting Solutions, Inc. These are two companies that have been acquired over the last couple of years, and the main purpose for that was to extend our geographical footprint. But then on top of that, and perhaps more importantly, is bringing in-house the explosive cleaning expertise. So these two companies have been in business for over 20 years, specializing in that space, as well as within the power plant industry. And that's where we really developed the KinetiClean technology with the explosive cleanings that we'll get into here later today. The one thing that I would show on the right to bring to everybody's attention is the map that we show for our locations. We have several different locations scattered throughout the U.S. so we can support everybody's different needs in different geographical regions, and even to the point where we're actually now supporting opportunities and projects within in the international space as well. So happy to help in any area that we can for our clients. An important aspect of any discussions within the power plant space, and in reality in any industry for that matter, is safety and training. One of the things I wanted to bring up before we get started is to really discuss and address this safety item. The technologies that we're talking about today, as well as all the different services that we do, there's always some aspect of it that we need to monitor from a safety standpoint, whether it's setting up scaffolding or guys just coming onto your plant and just walking around for that matter. The thing that we hold very dear is our EMR rating, our experience modification rating. And so that is what the insurance companies are using to determine really how safe we are and how much they're going to charge us for our insurance. One is actually a typical baseline, your average for most companies. We're actually, as you can see, operating at about a 0.81 and have been relatively consistent over the last several years. That's pretty much world class from that standpoint, and it goes to show that safety is a priority for us. This is not something that we've just fallen into or got lucky. Over that period of time, it required a lot of effort and a lot of having a lot of people eyes on it and being a priority within the company. And the way we do that are those things that you see on the left-hand side. The OSHA-based safety trainings, OSHA 30, for example, being involved with all our employees for that, quantitative testing and training, having tailgate meetings at all of our jobs, having job walks, site walks, doing all of those things and understanding a client's requirements as well as making sure we implement our own safety requirements, which may be above and beyond that of our clients. And the other aspect of it, and probably the most important, is that the safety is a aspect that goes from our field personnel all the way to our CEO. Everybody is cognizant of that requirement and the importance of that. So that's how we're able to maintain that EMR rating over the last several years. As we get into the safety side of it, that's where that's the baseline for everything we do and the services that we provide. And to speak on the services that we provide, actually have Jack Deaver, who's going to walk you through the reasons why you would do HRSG tube cleaning to begin with.
Thanks, Jorge. I guess we'll try to do this one together. Hello, everybody. Pretty basic here. Benefits of system cleaning. There's usually only a few reasons customers want to clean their plants, but the key issue is fuel efficiency, which leads to an increase in megawatt output, which is great. Improved heat rates, which is great, and all the buzzwords we use. One of the key things is, the industry has researched a lot of issues with water column and saving money and reduction of gas turbine exhaust pressure. So heat rate's a big deal. I think, Jorge, I'll pass it over to you in a minute to walk through the graph. It's a little busy, but Jorge does a great job explaining that. Increased heat transfer, obviously a major issue with you guys. Improved steam production, which leads to overall power output improvements, and reduced stack temperatures. That's always an issue with each plant. So Jorge, I guess looking at the graph, we can talk about the red line and temperatures, but I'll pass it over to you.
Sure. Thanks, Jack. Yeah, as Jack was saying, so the reasons why you're going to implement or anybody implements the tube cleaning is to increase, as Jack mentioned, it's for system maintenance and some returns on investment. System maintenance, the more you clean it, you're able to get a better view and line of sight to the materials of construction, the weld joints and the headers and those aspects, so you can do better PM on it from a visual inspection standpoint. The other part of it is here that we're referring to those cost savings. And as Jack mentioned, with decreasing your back pressure, there are implications associated with the operation of your gas turbine. So as you can see on the graph, if you look at the red line where it's the gross heat rate, that's what that's plotting. On the x-axis, you have exhaust static pressure loss deviation, which is a lot of words, but really what that is impacts to your back pressure of your gas turbine. Are you reducing your back pressure? Reducing back pressure drop through your tubes. That's what that equates to. And then the correction factor is either an improvement or a reduction in aspects, whether it's a power output, or the exhaust temperature. So on the x-axis, you're seeing if you go from 0, the center point of all those lines, you'll see that that's 0 pressure loss. If we go to the left, -1 inches, you'll see that would be if we were to clean your tubes, that you were able to reduce your back pressure by 1 inch of water column, which isn't all that much, you would see a decrease in your gross heat rate. And it's equivalent to about 0.12% in that case. So for every inch you drop, you can get about 0.12% decrease in your heat rate. That means that you will use less natural gas or fuel for each megawatt that you create. Huge benefit there when you're running base load. In addition, you then have the green line, which is your gross power. Gross power, if you go and reduce back pressure by 1 inch again, you would actually be looking at about a 0.1%, 0.14% increase in your power output. So that 1 inch of water column is going to give you more power output, and it's going to do it more efficiently. So you less fuel used to create that megawatt. So both of those things have implications from a cost saving standpoint. In addition, you'll see the exhaust temperature line, which is the dark blue line. Not as strong a slope on that one, but what that's showing us, and it's harder to quantify in terms of numbers, to say for every inch, you'd be able to see this kind of benefit to exhaust temperature. What that really relates to is actually the heat transfer. The more we clean off the tubes, the more you're able to get better heat transfer through the tubes. You create more steam. And then whatever you're doing with that steam, whether it's power production or steam for cogen, in both applications, you're benefiting from that. And this Matthew Weimer asked if this is actually based, if this chart here is based on a HRSG tube, full tube cleaning. This in reality is more so the chart that gives the concept and the orders of magnitude, let's say, for the correction factors. So this isn't necessarily saying that for this chart here in particular is not plotting out. We didn't put the points on the lines to show a specific decrease. It's just really showing you that on a rule of thumb would be that if you're able to reduce your whether it's your exhaust temperature or your heat rate, that you're able to improve on those based on reducing your back pressure. The part that is a correlation to actual an actual application is below, where you actually see the dollar amounts, and that was based on an actual what would be considered an actual operation of a 201 megawatt gas turbine operating at base load for 8,000 hours per year. And that would be if it had 4 inches of water column of back pressure due to fouling, and you did a KinetiClean, you would see 3 inches back. So you would recover that. So you would actually be seeing, this kind of reduction on the gross heat rate. You'd get it to about 0.9975 percent, 99.75% correction, and then on the gross power, you see a correction there as well, improvement on the power output. And these numbers are based on those dollars per megawatt and the cost of natural gas at $5 per million BTU. We'll go into it later that we have a calculator that can be used to calculate this, so you can run this for your own personal applications as well and take a look at it that way. The one thing that I'll mention here is that, and it'll probably it may get reiterated later on, there are differences in the type of technology that you use as to how much recovery you can get. So we're going to get into that here in a little bit. Jack, you're hand it off to Jack. Talk about where
dry ice blasting. I think everybody is super familiar with this, also called CO2 cleaning. 25 years. People have been doing this. Very common, somewhat affordable, kind of an industry standard. Used with HRSGs now a lot, rotating equipment in many industries, gas turbines, miscellaneous equipment, pumps, a lot of different equipment uses. So some big advantages. Leaving no residue on the tubes might be the biggest one. That's kind of how dry ice entered the world. Didn't leave any residue on close tolerance pieces of equipment. Sufficient force and mass to provide adequate cleaning, which is great. So it does a good job. Some disadvantages. Dry ice only gets what it can see. We can only clean what we can see, and that's everybody who does dry ice, not just Groome. So tube spreading came along, Some people will do it, some won't. If employed, it can damage tubes, but it does allow you to get a little deeper into the system. Like I had just said, everybody can only get 2 or 3 rows in with the dry ice. It's a disadvantage. So you're not getting everything. There's scaffolding, which brings in safety issues, impacts schedules, adds time to the job. And dry ice isn't as available as it used to be. If you don't plan ahead for it, you can run into problems there. One of the things with dry ice, everybody, I don't know if it's a disadvantage, but it's chemistry. It sublimates a little bit, evaporates, and the longer it sits, the less effective it is. So that's important. So once it shows up, on site, it's important, we put it to good use and get it to work right away. But very common. It's what Groome started out using before our KinetiClean. And it's still part of our life, big part of it. So thanks, Jorge. You can move on. Any questions?
And I'd say there's one other thing on that before we move on, that like Jack said, the effectiveness is dictated by the size of the pellet, the hardness of the pellet, and if it can see the tubes. With dry ice, we normally see, because we still apply it today, we still offer it today, we would see about a 30 to 50% recovery of that back pressure that we were showing on the chart earlier. Any back pressure that you've accumulated over time since the last cleaning or since the startup of the system, dry ice can recover about 30 to 50% of that. So if you were running 4 inches above your startup conditions, a dry ice could get you somewhere to 1.2 to 2 inches of water column back. And then, so that's an important aspect of it, and you'll see why here in a second. And so Matt Cohen's going to discuss the KinetiClean technology.
Thanks, Jorge. Yeah, like Jorge said, there are some limitations to what dry ice blasting can do, how effective it can be. Really it comes down to taking a look at your system. We can look at it from a very analytical standpoint and assist with deciding, what is the best method to use to accomplish your goals with the current conditions at your plant. But KinetiClean is a much deeper cleaning, and it's based off of this 3-step process. So we use the kinetic shockwave. We create a det cord curtain. We position that in the unit adjacent to the tubes that need to be cleaned. Once the blasting is completed, or based on how the schedule's designed at your plant, it's followed up with an automated high pressure, high volume air vestibule that is put into the unit. So we utilize the sky climber ports for both step 1 and 2, and that air vestibule automated moves up and down, side to side within the unit. And what that does is it knocks the debris that was loosened from the kinetic shockwave down to the floor of the HRSG, off of all of those tube fins that act almost as shelves holding that debris. And then once that is all knocked down to the floor, we remove the debris by means of vacuum. We get down into the basement behind the baffles, off the lower headers, and remove that. So we had a short video clip here so you guys can kind of get a visual of what this looks like.
KinetiClean utilizes kinetic energy to dislodge the fouling deposits on your fin tubes. A detonating cord curtain is engineered for your specific application based on the size of the area to be cleaned and the amount of fouling of the individual HRSGs. The detonation itself is engineered to be the most effective in delivering kinetic energy while ensuring the structural integrity of the tubes is not compromised. There is no tube spreading required, and no tools come into direct contact with the tubes. After detonation of the det cord curtain, there will remain some fouling material that has been loosened, but still remains on the tube fins. KinetiClean utilizes a patented oscillating air tool to deliver high volume, high pressure air through a programmable operated system to remove any loose fouling that may remain. This high-volume, high-pressure air removes remaining fouling material previously loosened by the kinetic energy system. After extensive testing in our R&D center and several industry case studies, we have concluded that the kinetic energy produced by the detonation of explosives with the application of our patented technology produces a safe and effective cleaning method.
I'm not sure how clear that was for everybody, but that's just a short outtake from a video that we have available on YouTube that you can, I'm sure you could look up and see the entire thing. But these are some real world pictures of those steps that I was referencing before. As you can see in step one, this is the curtain that we create inside the space, and those red lines that are hanging down is the actual det cord. It looks very similar to like a Cat5 Ethernet cable. And basically we're using a beam and lifting it up to the top of the unit with the det cord suspended. And we're fastening that to the bottom so nothing's moving in the unit. And then we attach the blasting caps to that, and the detonation moves from cord to cord to cord from one side of the unit to the next sequentially. And like I said, following that, once all the blasting is done, which is determined by our blasters and based on how much fouling is in the unit, those are the factors that determine how many curtains we will be hanging in the unit. We then introduce the air. So that's step two. There is that box beam that's in there that rides up and down, starting at the top. There are normally two, depending on the size of the unit, that move sidewall left to center, and then the other one would move sidewall right to center, and it would basically step down as it moves down through the unit, starting at the top, ending at the bottom, knocking all that debris down. And then following that, we're left with a pretty big mess in the bottom of the units, and so we remove all that with the vacuums, like I said before.
So here we have a video that hopefully won't be as choppy, that'll go through and show you actual live footage of the KinetiClean.
From inside.
From inside. So that video never gets old. I can watch that. I can watch that all the time. Actually, we have a poll that I'm going to put up right now. You should be seeing on your screen, which will take 30 seconds here before we continue on with the webinar here. Just asking if you are seeing at your site, if you are seeing increased back pressures due to fouling of the HRSGs, or at least what you would assume would be fouling of the HRSGs. Of your HRSG, and then as well if you plan on cleaning your HRSG tubes within the next 12 months. And as we mentioned before, those aren't necessarily they don't necessarily have to go hand in hand. A lot of times we have clients who are looking to clean their tubes just based on visual inspection, knowing that there is some, even though DP or differential pressure may not be all that high, they're seeing the benefits from heat transfer. So we'll give a few more seconds here for you guys to answer, and then we'll continue on with the webinar. And I'll just give you a heads up. It looks like looks like you guys are doing better than average in terms of how high your back pressures are. It looks like for the most part, the majority are not seeing too high a back pressure, so that is good. It eventually happens with time and operation, but so that's good. And then several of you are looking to have HRSGs cleaned here in the next 12 months. So with that, we'll continue the webinar. I appreciate that, and we'll continue with Matt and going through the why KinetiClean.
Yes, that video is great now that we have that, just so people can understand, what it looks like, what it sounds like. So the first little popping that you heard, that was the blasting caps, going off, and then following that, you heard the det cord detonating. So why KinetiClean, right? So is it safe? It is. We use det cords, not dynamite. It's a flexible explosive. Like I said before, it's like Cat 5 Ethernet cable. It's a core of PETN encased in an outer plastic jacket. It is inert until that blasting cap is attached to the actual cord right before blasting. Nice thing about it is there's minimized exposure to particulate. As other cleaning methods, there are not people within the unit when the cleaning is happening. No explosives come in contact with anything inside the gas path, so as not to damage anything. When we do hang that cord, it is, it could be anywhere from 16 to 24 plus inches away from the face. So it is suspended and not in contact. The nice thing about this is other contractor work can be performed while the det cord is being placed. So it's in terms of timing between blasts, you generally have anywhere from 2 to 3 hours between blasts when we may be doing other work within the gas path, such as a catalyst cleaning. That work can still be performed between the times that the blasting is happening. So another advantage there. Everyone that's involved in this process is highly trained and licensed to do this. Just to review the advantages, this type of cleaning is more effective at removing the fouling that you're going to find on your HRSG, whether it be just rusting and corrosion, or if it's ammonia salts. When we look at these things, we're looking at it from a system standpoint. If we're seeing a lot of ammonia there, it's gonna maybe raise the question of, well, why are we seeing so much? Maybe we're looking at there being some elevated slip, and we can assist with that as well. Like we talked about before, dry ice blasting really is only effective at cleaning the first 2 to 3 rows of tubes in a bundle. This is a much deeper penetration into the bundles, and setting those multiple shots just gets deeper and deeper. It is a lot faster than doing ice blasting because you don't have the setup of scaffolding. Everything is automated, and we do perform this working day night. So we've got a day shift and a night shift. A typical HRSG cleaning is on average is about 4 days, 8 shifts, depending on the construction and access to your unit. It also depends on how many bundles that we are cleaning, which ones need it. So obviously fewer bundles takes less time. Like I said before, also, the spacing and the load of the det cord, anywhere between 17 and 50 grain dead cord is used based on what you've got going on inside there and how it can be the most effectively cleaned. Because our technology is hanging a curtain, if you will, from floor to ceiling, wall to wall, it is 100% full coverage cleaning. So we can clean multiple faces simultaneously. When we set those shots, if we were to clean an entire back end, from an SCR catalyst, if you have one, to the stack, we would rig all of those curtains together, and basically they would be daisy chained together, and so it would work from one alleyway between bundles and work its way through the unit. We don't move any of the tubes manually. We're not getting in between there, causing any damage or creating a risk. And like I said before, we don't require any scaffolding.
Hey, Matt, before I continue on, I just thought to put it in perspective for everybody, like you said, it's much quicker, multiple two faces simultaneously. The video was that, I believe that might have been 2 curtains in series.
Yeah, that was one bundle. I believe that was we did both sides of that bundle, but the view from the camera was just one side. So you heard that going across the back and then back across the front.
Right. So it really would have cleaned, in essence, 3 bundles, right? Fully cleaned one, the downstream and upstream faces, and then an upstream and downstream face on the bundles, upstream and downstream.
Yeah.
So
that's a great point. So talking in terms of, what do we see more of? If we look at a HRSG, we're for the most part, we're seeing that fouling really from the back 2 bundles within the cold section of the HRSG. And so if that was the case, we would hang a curtain on the downstream of the last bundle. So it would be the downstream of the last bundle, and the other side would just be the stack. And then you would hang another one between that bundle and the next one upstream. And then if you were cleaning the back 2, you'd hang one more. So on that one that's between on the one that's between a bundle that we're saying is we're cleaning versus one that we're not cleaning, it's still getting the effect of that kinetic shock wave into it. And you're also benefiting because the air vestibule, when we put that in, also blows both upstream and downstream to keep itself centered in the alleyway. So you do get cleaning effect, just by being in the vicinity of the whatever upstream bundle is there from the last one that you're basically selecting to be cleaned.
Mm-hmm. Yeah, that's good. Thank you.
This is just a case study from a cogen facility in Texas. This unit had never been cleaned in over 20 years, and they were actually derated, operating at 75% of baseload. The plant was in jeopardy of not being able to deliver on their steam requirement per their contract with as a host. And so after KinetiClean, we spent 8 12-hour shifts, 4 days. We were able to recover 6 megawatts for them, 12%. And we were able to decrease the stack temp by 12 degrees. We got 20,000 pounds of material out of the unit. And, the result was the plant was able to run near baseload and fulfill their steam host requirements. Getting some background noise there.
Is that all right?
There we go. This is one up in the Northeast. This one, the plant had used dry ice blasting with tube spreading in the past, and they had only been able to see about 2 inches of water column decrease in their DP. So before we came in, they were at 18.6 inches of water column. Stack temp was up. When we were done, this was a 3-day job. We were able to decrease their back pressure by 3.6 inches, just about double the effectiveness of doing the dry splasting with the tube spreading. And we got about 7,000 pounds of material out. And based on that calculator, it was about $500,000 of savings that the plant saw in terms of ROI.
Thanks, Matt.
Yeah.
So Jack is going to speak about Jack and Ryan are going to speak about the KinetiClean calculator.
Yeah, everybody, this is on the Groome website. Great tool. It's helped us a lot. And it's fast, which is great. But there's two reasons, and I'm taking this from Matt. There's two reasons why customers are cleaning their HRSGs. They see it, it's dirty, safe, best practices, and then obviously they want to try to have some cost savings. So this calculator gives you a quick view at what you can really see down the road. And Ryan, I'll pass it over to you. I know this is your baby, so you can walk through it.
Yeah, appreciate that. Yeah, and like Jack said, this is basically trying to put a pin in the roadmap of, is KinetiClean something that I want to do? Is it going to be beneficial for my plant? And the first step to, I think, figuring that out is to use the calculator and kind of give you a ballpark estimate of what you can achieve as far as an ROI is concerned. So it's a pretty simple calculator, and you can plug in these points directly from, your plant. So it's, the gas turbine size, and the calculator assumes that you're going to be running at base load for the number of hours per year that you input next. So that is one thing to keep in mind when you're inputting these values. So it's estimated at base load for the number of hours. And then just simple pricing is, how would we get the price for each, cost savings for fuel and the additional power output. And then the biggest one here is the DP at commissioning versus the DP that you're currently running at. So the calculator assumes that that a cleaning would achieve 75% recovery of the DP that's gained just over the years from fouling of tubes or whatever it's causing the issue in the HRSG. Now, if you have a specific tube bundle or section that you're interested in, you can input values for that and not input exactly what it's saying here. What the calculator does is it takes those values and then it uses the 75% cleaning effectiveness. So that'll put you on the kind of on the roadmap, and it uses the correlation curves from the plot that we had discussed earlier. There are obviously turbine specific operating curves, performance curves that we can use. So if you have those and you'd be interested in finding out a little bit more in depth, what exactly am I looking at? We can give you that along with like some operating data and give it like a little bit more of a in-depth analysis. But this calculator is great just to give you an idea of like order of magnitude. What am I looking at? And it makes it a little bit easier to make that decision.
Yeah, thanks, Ryan. That's a very good point. So this tool was put out there for the benefits of our clients because they were asking what return could they see. The one thing that I guess I'll mention just real quick before we move on the slide is, it is asking for what is that back pressure that you are seeing. A lot of our clients, if they want to get more granular or understand better what the two bundle, pressure drops are in each bundle, Groome can provide that service to you, and at minimal cost to come out and help determine that, to take readings actually between the two bundles, even your catalyst beds, so you can get a better profile overall of your pressure drop and where you maybe are accumulating that fouling, whether it be in a catalyst or it's in the economizer section, whatever that case may be, and then it allows us to better tune where to clean for you. So that's a service we can provide that helps make everything a little bit more, more meaningful and better value from that standpoint. And why Groome? And Jack was going to speak to this.
Yeah, this is kind of a quick overview. of who Groome is and what we've been talking about the last 30 or 40 minutes, with 25 years of experience in the blasting part, close to 100 years as a company. Safety, world-class rating, super important to everybody who works there. And this isn't a high-tech industry, but we've got patent technologies. It's innovative for what we do. Our crews are great. I'm new. I'm less than a year with Groome. Met the crews. They've been really, really good to work with, good with the plant. Certified by several OEMs. That's huge. Certified and approved. Jorge, I know you're going to talk about EPRI in a minute, Siemens Energy, and we can support you throughout the country. As we noted before, you saw the map, many locations, support all through North America. One of the things, Jorge, I wanted to mention, I forgot, was during these outages, it helps us with HRSG inspection, right? Oftentimes we don't get to see it. So if you do have outages and there's no HRSG cleaning going on, we'd love to come in and do an inspection. Yeah, they're free. We take pictures. If you're looking out a year in advance, it's super helpful for us and you, so we can get eyes on what we're looking at, right, Jorge? Is there anything you can add to that?
Yeah, no, that's a very good point. That we can, we offer that as a service, again, as a value. In addition, in essence, in addition to that whole profiling, pressure drop profiling that we can do for you as well, where our guys can come out if you have a little bit of time during your outage, that we can get inside, go through your whole HRSG from the first section, from the outlet of the gas turbine all the way through to the stack, and we'll actually go through there, analyze it, look at it, and then we can come back with any recommendations based on what we see. Again, there's no cost, and you end up getting a set of eyes on it from people who have seen hundreds of different HRSGs, all the different manufacturers and all different vintages as well. So certainly, happy to help, from that standpoint, and and then we can help develop a baseline as to where you are as well. So that's a good point, Jack. And like Jack said, they're certified by several OEMs. We're certified. You'll see on the screen here, Siemens Energy has approved us as a vendor for the KinetiClean technology, as well as some of our other services also. And we're also certified, although that's for another webinar, with the Catalyst OEMs as well. But that speaks to the expertise that we bring, the safety aspect, all of those things rolled up into one is where those people vouching for us and certifying us is extremely important. And then on top of that, we've done work, third-party testing for KinetiClean with EPRI. And in fact, we're going to have Ryan maybe speak to that. He's been involved with a lot of that testing, and he can speak better to that than I can.
Yeah, appreciate it, Jorge. So just to give kind of an additional bolster behind the fact that, KinetiClean is like a safe technology. We had been obviously cleaning with explosives for, a couple decades now, but a third party like EPRI having their kind of stamp of approval goes a long way with just kind of easing any concerns from a safety standpoint, or from just overall what could happen if I use this technology in my plan. So EPRI, obviously third-party organization, we came up with a testing plan where we tested, different grain deck core, different proximities to the tubes, different orientations, and we simulated a cleaning. So it's going to be, multiple blasts for one set of tubes. And then after the blasting is complete, we would take those tubes and then they would undergo some, scrutinized testing as far as, eddy current testing or MP testing, or, a bunch of the different kind of non-destructive and actually destructive testing. So we looked into the metallurgy too, to see if there was any changes. And we have the whole study is on EPRI's site and is available for anyone who's a member. But it was very successful and kind of proved what we kind of already knew, that the technology was safe, but it was good to have their stamp of approval. So
yeah, no, that's a good point, and I think you may have mentioned that that report is available to members, and if you wanted, we can always supply that report number for anybody who's interested. Just feel free to email us or even put your name on the Q&A or chat, and we can get that over to you. So from the webinar standpoint, that's the discussion that we wanted to have, and hopefully you've gleaned some information on why we really developed, why the technology was developed to begin with, and really the benefits of it. There are some questions here that we'll go through, no specific order necessarily. So we'll start with, let me go to the first one. Would the fouling of the tubes, for example, ammonia, sulfur, iron oxides, etc., dictate what kind of cleaning type you would do? Matt, do you wanna take that one?
Yeah, I mean, I think one very important thing here is as much as we want to clean everybody's HRSG, we want it to be justified, right? I mean that's the real the big thing. As a plant, you need to justify why it's a good reason, and we don't want to clean something that doesn't need to be cleaned. This is a great question. I think the technology that you pick is not based off of what type of fouling you have. It's really more based off of the construction of your HRSG and how thick your tube bundles are. For example, if you've got tube bundles, which is rare, but we've seen it, where you're only 4 to 6 rows of tubes deep, ice blasting is going to be a very effective way to clean that HRSG. But if you're deeper than that and you've been running for a number of years and that fouling is basically compounding deeper in that bundle where you can't reach it, KinetiClean is going to be your answer. With us setting the bar for ourselves, or the expectation of the 75 to 80% recovery, that's a conservative number for us because we want to meet or exceed your expectations. The longer you're waiting to clean your HRSG, you're going to be leaving more material deeper in those tube bundles. So, it's really going to be up to each plant to decide how often they want to do a cleaning. Do they want to do, an ice blast? Do they want to do KinetiClean? It really depends. I think the thing that sets us apart as a contractor is we offer both types of cleanings, and we really approach every opportunity with a partnership standpoint, saying, hey, if this was our plant, what would we do? Because we want to show you guys the best value, for what you're looking for to solve the problem. So that's why we're here.
Mm-hmm. Yeah, I think that's a good point. In terms of, and would you say we haven't? Oh, sorry. Go ahead.
One other thing I'll throw in there. The thing that wasn't mentioned there as a foulant is insulation, right? So we have had instances, and I'm sure everyone's heard about liner plates blowing loose and insulation getting blown on the face of a catalyst, and that causes DP as well. We've seen this be very effective, KinetiClean be very effective at that, even when it's deeper into a tube bundle. But I would say air lancing could get you, the recovered, could recover some of that back pressure as well. So.
Yeah, and I would add that we, on those items, we haven't, with the KinetiClean, we've been, it's been effective on all different types of fouling that we've addressed at this point. And I'd say really what we probably do look at versus whether it's not necessarily like Matt said, not dry ice versus kinetic shockwave. It becomes, do we change the configuration of how we're doing it, or do different grain det cord, so more forceful det cord, for example. So there's lots of different ways we can address that.
And on that note, I'll jump down to two questions to this one. If your HRSG gas path has 3 to 4 horizontal partitions or floors, or I'm assuming you're talking about buck stays or permanent scaffolding, can you perform KinetiClean? So I think it's interesting. This is a great question because I use this as an example. Our technology is very customizable. We've been approached by some engineering firms that have been tasked with looking into the different technologies to clean their HRSGs because they have units that are designed like this. And we have been able to clean them where nobody else really was able to. That you're basically hanging a smaller curtain within each one of those floors. It takes a little bit of additional time, but we can accomplish the same results with a unit that's configured like that. It's a great question.
Mm-hmm. The next question from Matthew Weimer: has there been any tube damage from this type of cleaning?
Can we take that?
Sure, take it.
So we haven't seen any tube damages as a result of the cleaning, but what our teams do before they do anything in a unit is inspect it. There have been a couple units where there have been leaks prior to us doing anything, and we just bring that to the plant's attention, and they go noted. And then after we're done with the cleaning, they've repaired those. But we have not seen any damages from this type of cleaning. And Ryan talked about the testing we've done with EPRI. I mean, those guys, nothing was breaking. So you guys get a bunch of guys with explosives out, in a field, blowing stuff up. Like we want to see something break. They tried to push it to the point that they did see some damage. The only thing that they could get to happen was mangling some fins on the outside of the tube. But even still, there was no structural damage to the tubes themselves, even when we tried.
And that was by wrapping det cord
Yes.
around the tubes. Yeah.
Yes.
So, which we would not recommend as part of
No.
our standard KinetiClean. So it's certainly been proven that from a damage standpoint that we haven't seen that at all. Another question from Yefim Koshler: are 5 Sky Climber ports enough to cover the entire face of the tube bundle?
4, yeah. We basically just need two Sky Climber ports on the outside edges of the gas path, as long as there are no obstructions inside that alleyway. So if you've got structural supports in there, that would, if you could imagine pulling down a window shade within a window jamb, if there isn't anything that's going to obstruct you pulling that down from the top down to the bottom, we only need those two outer ones to lift that beam up to the ceiling.
So really 2 per face, right? So 1 on the downstream, 2 on the downstream, 2 on the upstream sides of the bundle. Yep. Yeah. Jay Mullins was asking, so I believe this was asked regarding the second case study. Were there chemistry readings high after starting back up from doing the blasting? So the water chemistry, I guess I'll answer that one, Matt. I don't think we've typically gotten involved with their chemistry readings, but I don't think nobody has come back to us and said they've had any issues with their chemistry after implementing the KinetiClean, or for that matter, even with obviously with CO2 either.
Just a couple things to add. One to the Sky Climber ports. If you do operate a plant that does not have Sky Climber ports, we would look at that and determine if we need them. Sometimes if there's an attic space above and there's a floor in that attic, we can pop down through the floor of the attic without putting penetrations through the roof of the unit. But if you do require Sky Climber ports, we do also install those turnkey as part of the project, and that would obviously be a little bit more time on the front end of the job. But jumping back into the chemistry, I know this is something that EPRI has been looking at, and we haven't heard any concerns from them. We've had some people say, oh well, if you do KinetiClean on the back end, is there a chance that there could be stuff loosened within the tubes that could end up flowing to the steam turbine and causing there to be a failure there. And EPRI has answered that with, well, it's actually, pretty much impossible for that to even happen because the water has to change state. For it to take particulate to the steam turbine would be impossible because of the chevrons and strainers and everything that are there and changing state. So, and I will also say that if anyone does want to talk in more detail about some of those findings or talk to anybody at EPRI, they have made themselves available to any customers that are interested in doing this that might have concerns. They're happy to speak to anybody to answer any questions and have those conversations too. So whoever your rep is, I would just shoot an email and we're happy to make that happen.
Yeah, and I would say on that too, I was having discussions with EPRI before as well on that tube fouling, and typically where people have seen more of the fouling, the harder fouling, is on the upstream, the upstream tubes, the hot sections, which is not really where we're typically doing. We're normally, more often, probably 9 times out of 10, we're working on the back end in the economizer section, the cooler section, which doesn't have those kind of buildups, let's say. So it's even more of a less of an issue from that standpoint in that area. John Cooper was asking typical cleaning frequency, and I think that's a tough one for us to answer with any certainty, I guess.
I would say, in a perfect world, we want to know what each bundle is contributing to your overall back pressure. The only way to know that is if you were to put instrumentation in there or put a port so that you could take DP readings on every bundle. I guess I would say as long as you're monitoring your DP and you know where it's coming from, the fouling is going to determine how often you're going to need to clean. And if you have that, some plants even just take a port, they'll pipe down to an isolation valve and they'll put on even a quick connect that they could just put a gauge on, and they'll go out on a regular basis, or they'll just leave a gauge on there and just track the DP. That's really the best way to know how often you should be doing the cleaning.
100%. Yeah. And I would say, we have the range we see though is from 1 year, people doing it every year, to some that haven't done it in quite a bit of time. As what Matt said though earlier, if you let it run too long, your fouling can get so bad where you're not able to recover it. An 80%, 75% recovery still may not be as good as you want to get it. So doing it, I think probably on average, we look 3 to 5 years is what probably the average falls into, somewhere in that range. But like Matt said, the best way of doing it would be having eyes on and understanding where that pressure drop is coming from, so we could accurately pinpoint where to clean and get you the most effective, bang for your buck. No pun intended on that. So I think that's a great way of doing it. Those are all
great questions, though.
Yeah, no, fantastic questions. And happy, and I guess I'll say, it's 2:59. We're happy to take any more questions that you may have right now. If you think of them afterwards, like we all tend to do, feel free to reach out to us. You have, with Matt, Jack, both are the, like I said, Midwest and the Northeast reps. Myself can be contacted. Feel free to call in to us, and we'll be more than happy to help in any way we can. So thank you again for all joining. Look forward to helping you with any KinetiClean issues and any other kind of issues we can help with in the future. Have a great day. And thanks to the team for doing a great job on the webinar.